It's also possible for a quadratic equation to come about from an application or a function. In this case, we're told that the revenue in dollars from sales of X passes to an amusement park is given by this function, R of X. How many tickets must be sold for the revenue to reach $4,000? The first thing that we need to consider in this is the question of whether we were really given a value of X or a value of R of X. Since X is the number of passes and revenue is given by the function R of X, we can tell that this is telling us that R of X is equal to $4,000. So we are going to set the whole function equal to 4,000 rather than plug in 4,000 as a value of X. So the first step is to determine whether we were given a value for the input variable or the output variable. Then we can substitute in our function minus 0.02 x squared plus 24x in place of this R of X, keeping the equals and the 4,000 exactly as they are. There are a lot of options for how we might approach an equation like this one. I would start by at least getting all the terms on the same side. In this case, because my leading term has a negative coefficient, I'm going to choose to move these two terms over to the right to make that leading coefficient positive, because all of the methods we have are easier with a positive leading coefficient. So this is going to become 0 equals positive 0.02 x squared minus 24x, and the 4,000 didn't move, so it stays positive, plus 4,000. We can clear decimals if we wish in this problem. Clearing decimals would involve multiplying both sides of this equation by 100, so that we would get rid of the 0.02 and that would become 2x squared. However, it would also make this 4,000 become 400,000. So in this case, I personally would leave the decimal numbers in here just to prevent getting the other problem, which is numbers that are so big that sometimes it's hard to keep track of how many zeros you have. You could factor out a common factor of 2 if you recognize that, bringing this down to 0.01 x squared. And you also could attempt to factor this polynomial. Lots and lots of options. What I'm going to choose to do is just take it exactly as it is. A equals 0.02, B equals negative 24, and C equals 4,000. Plugging into the quadratic formula gives us x equals minus b is going to be positive 24 plus or minus so minus 24 squared minus 4 times 0.02 times 4,000 divided by 2 times 0.02. Let's start working on these computations. 24 squared is 576. And 0.08 times 4,000 gives us 320. Divided by 0.04. Now 24 plus or minus the square root of 256 divided by 0.04. 256 turns out to be 16 squared, so this is 24 plus or minus 16 divided by 0.04. In order for us to go any further with this, we're going to have to combine the like terms in the numerator, which means that we're going to need to break apart this plus or minus symbol. This only becomes necessary when your solutions are rational numbers. Because we had a perfect square, 256, in our square root, we were able to get rid of the square root, and we end up with an expression that we can actually combine. So one solution is going to come from 24 plus 16 over 0.04. The other is going to come from 24 minus 16 over 0.04. Let's figure out what each of these is. So we ended up with two solutions, both of which are rational numbers, 1,000 and 200. Sometimes it's the case that when we get more than one solution, we have reason to throw one of them out. We need to look back at the original problem to try to figure out whether these are both reasonable answers. Remember that X is the number of passes, or the number of tickets sold to an amusement park, and R of X is the revenue. In this case, they do both seem like reasonable answers. Neither of them is negative, and neither of them is going to give us a negative revenue either, which we could verify by just plugging them in. The reason we can get two answers to something like this has to do with how this function is composed. Because this revenue function takes into account some supply and demand, we don't assume that if you sell more passes you necessarily make more money. We are assuming that if you sold more passes, you probably sold them at a lower price per pass. So there is kind of a peak point, which is what we're often interested in finding, but is not what this particular question is asking about. Because of this, if we're a little bit smaller than the number of passes that would get us that peak, then maybe we're at this 200 here. Or if we have a greater number of passes than would give us that peak, we could actually see the same revenue for both of these inputs. So both of these are reasonable answers, and our final answer is going to include both of them. We could sell 1,000 passes, or we could sell 200 passes. In both cases, I'm going to make a revenue of $4,000.